So as we review chapter 11, the line of thinking is similar to the line of thinking for chapter 10. We have to first recognize the type of problem that we have. Okay? And the very first problems we talked about are what I call simple probabilities. So you know it's a chapter 11 problem if you're talking about probability. You know it's a chapter 10 problem if it says how many. So a simple probability would be like you have an apple, an orange, a pear, and a strawberry. What's the probability of someone randomly choosing an orange for you to eat? That'd be 1 out of 4. So you're going to be able to recognize those very easily. Okay. Now, if it's not simple straight up, then we're going to check to see if it's an OR probability. If it's an OR probability, you're probably going to see the word OR in the problem. The OR probability formula, remember, is very much like the how many probability formula, except it goes the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Scrunch out, David. Make sure that gets on the screen. Okay, so if it's an OR probability, that's where we're going. That's the second thing we'll check on. Let's change the color a little bit. The next thing we need to check to see is if we have an AND probability. Do you guys remember the formula for AND probability?
Probability of A plus probability of...
Keep going, Caitlin.
Is it times the probability of B given that A occurred?
There you go. Probability of A and B equals the probability of the first times the probability of the second, given that the first occurred. We assume that the first occurs and we find the probability of the second. So I check for those three things first. If it's not one of those three things, then it's probably going to be one of the two things that we talked about earlier in today's class. Okay, so it could be a binomial probability. Now this is a little hint. I probably shouldn't tell you this because you could get this right without understanding really why it's a binomial probability, but I'll tell you anyway. If it says, find the probability of getting exactly how many ever successes, a lot of times if it says that word exactly, you're looking at a binomial probability. What really makes it binomial is two possible outcomes. So on those problems, we're going to apply the formula that we applied earlier today many times. Combination of n things x at a time, little p to the x, 1 minus p to the n minus x. I'll give you that formula. Let's see, the only other formulas we got were number of at least one. We had or, how many with or. And then these two, right? That was it, wasn't it? What am I missing? And those are pretty foundational. So far, this is the only formula I'm giving you, the binomial probability formula. And the only other thing that we have left are the expected value problems. And that's not really a formula. That was list all the outcomes, call those x's, get a column for p of x, get a column for x times p of x, add that column. And the only other thing I want to say before we start working problems here is, remember, if they ask you for odds or odds against, do the probability first, then convert that to odds, and then convert that to odds against. That's my suggestion. Always find the probability first, then worry about the odds. And that'll save your thinking a little bit. Okay, we're ready to work problems here. I think I want to go ahead and get rolling here. And so I'm not going to stop and take our break here. So let's go ahead and don't want to cut ourselves short here on the review. So the first problem I would like to look at is number 1, part E. Which says, suppose a single die is tossed, find the odds against rolling an even number. Okay, so what are we going to do? First of all, is this a simple, we'll worry about the odds later. So the question right now is this a simple probability problem? Yeah, it's in there. You don't see multiple parts here, do you? Okay, so yes it is. So we're going to find the probability of rolling, what was it, an even number. And then we'll convert that to odds. And then we'll convert that to odds against. So we'll go in that order. So, James and Dustin, if I roll a 6-sided die, what's the probability of rolling an even number?
1/2.
Yep, it's 3 out of 6, which reduced to 1/2. Amy and Shamari, how do I convert 1/2 into odds?
You keep the top number and subtract the bottom number from the top.
Way to go. You actually said the last part backwards, but you got the right idea. You keep the top number, that's 1, and then subtract the top number from the bottom number.
Okay.
So 2 minus 1 gives you a 1 there as well. So the odds are 1 to 1. And the odds against, we're going to flip that. So if the odds in favor are 1 to 1, then the odds against are 1 to 1. And so, class, how about 1 to 1 for number 1, part E?
But if it was 1 to 3, the odds against would be 3 to 1.
That's correct. Way to go, Mr. Daniel. Okay, let's bust out number 4 next. And here, okay, it says to do it, let's do it, we can do it. But the page number's probably not correct, so let me correct the page number on number 4. It should say page should say page 586. So if you're wondering what page 586 has that's so important, it's the snapdragons problem. So let me read the problem to you again. Mendel found no dominance in snapdragons with respect to red and white flower. When pure red and pure white parents are crossed, the resulting big R little r combination produces second generation offspring with pink flowers. And the second generation pinks, however, still carry one red and one white. So when they are crossed, the third generation will be governed by table 3. So here's what happened. Remember, we called big R pure red and little r pure white. These are red up here, white down here. And when we crossed them using a product table, each one of the 4 offspring had a red chromosome and a white one as well. So we ended up with we ended up with 4 pink flowers. Okay, and then we crossed those. So here's a pink, red with white, that we're crossing with another pink, red with white. And when we do that, we'll get the third generation. One of those is going to be pure red. The other one's going to have a red and a white, so it's going to be pink. This one down here is going to have a white and a red, so it's going to be pink. And the other one down here is going to have 2 white. So it's white. So number 19 says, what's the probability of getting red? That would be this flower here. That'd be 1 out of 4. Number 20 says, what's the probability of pink? That would be these 2. It'd be 2 out of 4, or 1/2. And number 21 says, what's the probability of getting white? Which would be 1 out of 4. So make sure you know how to do some Punnett squares, and then the probability part of those is really simple if you get the Punnett squares correctly. Mr. Black only punt on 4th down. Well, it's a good point, but it's not exactly what we're talking about with Punnett squares. Ding. You only got 2 more weeks of those bad jokes. Okay, so just hang in there. Okay, the next problemo that we're going to take a look at will be, where'd it go? Number 5, part B. I'm going to ask a question of Michaela, and Caitlin helped us out a while ago, so we're going to go with Holden. So here we go. 10 pieces of paper, each labeled with a digit 0 through 9, are placed in the hat to be drawn. If you select a piece of paper from the hat, find each of the following. And part B says the probability of drawing an odd or a multiple of 4. So, if we go back to our list of types of problems, Michaela and Holden, is this just a straight up simple probability, like find the probability of getting ahead? No, it's not. Is this an OR probability? Yes, it is. Then I'm going to apply the OR formula. Okay, so we're getting the big picture in place here first. It is an OR problem, so we're going to go with the OR. So what are we looking here? Probability of odd or multiple of 4 equals probability of odd plus probability of multiple of 4 minus probability of both. Everybody good so far? Okay, so now I've got 3 blanks I have to fill in here, 3 little problems. So the first thing I got to figure out is, what's the probability of getting an odd? Well, let's see. I don't remember the problem. 10 pieces of paper labeled 0 through 9 are placed in a hat. If you select a piece of paper from the hat, find the, okay. Yeah, so 1, 3, 5, 7, and 9 are all odd. So that's 5 out of 10 pieces of paper. 5 out of 10. You can make that a half, but I'm not going to, because if we leave it 10, we'll automatically have built-in common denominators. Now, what's the probability of getting a multiple of 4?
2 out of 10.
What are the multiples of 4? 4 and 8, so that's 2 out of 10. Minus, what's the probability of getting a number that is both odd and a multiple of 4?
0.
It's 0. In this case, that's not always the case. If that was said odd or multiple of 3, then we would have had some, wouldn't we? But in this case, we don't. So how about 7 out of 10, class? For 5B. Okay. All right, so we got the big picture. Did you say 0 is what?
I just asked if 0 was considered an even number.
It is not considered an even number. That's why that question is a lot better if I ask about odds than it is if I ask about evens, because students are confused whether to count 0 as an even number or not. Okay, this is 6, part B is where we want to go next. Suppose we want to form 2-digit numbers from the set 1, 2, 3, 4, 5. Find each of the following. If one number is chosen from all those that can be made, what is the probability it will be even? Okay, so let's get the big picture in place first. Let's see which of these type of 5 problems that we have. And to me, well, really to anyone, there's not multiple parts to this problem, is there? It's just, if you're forming digits, what's the probability of getting an even? This is actually a simple probability problem. Okay, we don't need one of our formulas to figure this. Now, so let's go back down here and think through that then. So I'm looking for the probability of even. Now, some of you are going, I really don't know where to proceed on this. What I tell you about what you do on a problem if you don't know where to proceed, you look at the sample space. That's right. So let's think about the sample space here. I'm making 2-digit numbers out of 1, 2, 3, 4, and 5. So how many numbers would be in that sample space? Did you just hear the words, how many? It's a how many question. Is repetition allowed?
Yes.
It didn't say that it wasn't, right? So it is. So I should do what? Draw blanks. How many ways can the first blank occur?
5.
How many ways can the second blank occur?
5. 5.
Now I'm looking for the sample space. I'm not looking for the number of even. I'm looking for the sample space. So it can be 5 as well. There's 25 things that can happen. So 25 numbers can be formed. Now, how many of those would be even? And I heard you guys say 2 second. You were working this problem, weren't you? Let's think about how many. If I draw 2 blanks again, the first digit could be 5. But if I only want even numbers now, then the last digit has to be an even number. And I've only got 2 choices. So 2. So how about 10 out of 25, which is going to reduce to 2/5? So I would consider that one of the tougher problems that we have seen. I'm going to pause the video for a moment. We're going to go to number 8 next. Actually, I'm not going to pick on you yet, but your time's coming. Okay. Let's go to 8, number A. 8 part A. A's not a number, David. 8A. You are choose. Well, that's good grammar, isn't it? Just mark out the word are. You choose 2 books at random off of a shelf. 3 are mysteries. 3 mysteries. 6 are biographies. And 5 are encyclopedias. People still have encyclopedias sitting on shelves. Okay, whatever. Find each of the following. A, the probability of picking a mystery, and then an encyclopedia given replacement. Okay, so I got to think about who I'm to. I think I'm ready for Daniel and Karina. Go through your checklist of 5 problems. Figure out, do you think this is a simple probability, an OR problem, an AND problem, a binomial probability, or expected value? Which of those 5 do you think it is?
This order problem.
What did you say, Karina?
No, sorry, and probability. And probability.
He loves the 10.
He's waffling a little bit, so I'm waiting for him to sink in on and. It is an and. You are correct. That's right. It is an and. So if it's an and problem, let's use an and formula. And the and formula goes like this. The probability of mystery and encyclopedia will equal the probability of mystery times the probability of encyclopedia, given that we got a mystery first. Now notice on this problem it said that we're given replacement. So we're assuming replacement. So let's stick with Karina and Daniel. What's the probability of getting a mystery?
3 out of 14.
That's right. Oh shoot, I got this written right on your paper. Nuts. Oh well, anyway. Now, we're going to look for the probability of getting an encyclopedia, assuming we got a mystery. Well, since we replaced, it doesn't really matter whether we got a mystery or not. If we wouldn't have replaced it, would matter. But what have we got? 5 encyclopedias now out of 14 total still. So if you take 3 out of 14 times 5 out of 14, you're going to get 15 out of 196. If you gave that to me as a decimal, that'd be fine too. I'll tell you what, you can mark out 9B. I won't give you a probability of at least 1. I probably should, but I won't. Okay, so let's look at 9A. A group of 7 students are chosen at random at Shawnee Community College. If 5% of all Shawnee College students speak Spanish, find each of the following. A, exactly 3 of them speak Spanish. Class, is this a simple probability, an OR problem, an AND problem, a binomial probability, or an expected value problem? It's a binomial probability, that's right. Either they speak Spanish or they don't. By the way, I don't know what percent of our students speak Spanish. It's, I would say it's probably reasonably high compared to a lot of other colleges. Especially, as I'm sure you're aware of, many of our students from Cobden speak Spanish, especially. But we're looking for the probability of exactly 3. Okay, so that makes my x 3. That's what I'm looking for the probability of. My n is what? How many students did we pick? 7? What's my little p? 0.05. Okay, and this is the one formula that I've committed to giving you. We've done several of these problems even today. And so we probably remember that the probability of exactly 3 here would be a combination of 7 things taken 3 at a time. Little p would be 0.05 to the x, would be to the third. 1 minus p would be 1 minus 0.05 to the n minus x, would be the 7 minus 3, or to the 4th. So that should turn out to be 0.0036. So still not a very high probability if you pick 3 of those 7 students that they're all going to speak Spanish. Less than 1%, less than 0.5% even, according to those numbers. Okay, and finally, number 10. The game is played by spinning a spinner with the numbers 1, 2, 3, 4, and 5. If an odd number is spun, the game pays $1. If an even number is spun, the game pays $2. It costs $1.50 to play the game. What are the expected net winnings? Okay, so obviously this is an expected value problem. On all of those problems, we've set up our little table with our outcomes. The probability of each outcome. Multiply those outcomes times their probabilities and add that column. This asks for the expected net winnings. You can take care of the cost to play the game at the front or the back end. I like to do it at the back end. So if we do that, then the game's either going to pay off $1 or $2. It pays $1 if we spin an odd. So 3 of those numbers out of 5 are odd. It pays $2 if you spin an even. 2 of those 5 numbers are even. So multiplying, 1 times 3/5 is 3/5. 2 times 2/5 is 4/5. I don't know why I put 4/7. That doesn't make any sense. There we go. 3/5 and 4/5 is 7/5, which as a decimal is $1.40. If the problem would have said, what's the fair price to pay the game? $1.40 would be your answer. But that's not what it said. It says, what are the expected net winnings? So it's going to pay you off $1.40 per play over time, but it's going to cost you $1.50 per play. So basically, you're going to lose 10 cents a play. So you want to make sure you can do all of the review page, the problems we've done and the problems that we haven't. All of the answers are on there so that you can check yourself. And then from your text, from page 627, that's where you'll find the chapter test in your text. Again, the evens and the odds are in the back, so make sure you check these. 3 through 8. '23 and '24 are good. '27 and '29 are good. And that ought to put you in pretty good shape there as well. Okay.